Hello everyone. I'd like to quickly go over how I compile and run my C code on my Mac. So first let's run the terminal. You could find that in the Launchpad, or you could press Command Spacebar to open the Spotlight search, which will help you to find all of your applications. So I'm going to hit Command and the plus or minus signs to make the window bigger because the font can be small sometimes. Now I'm going to go over a few commands to navigate the file system on your terminal. So the first one is ls, which says list everything in the current directory. Right now we're in the user directory, and we have documents, downloads, and a couple of different folders, and pretty much everything that is in that current directory. If we wanted to, let's say, open the music directory to move into that directory, we would do cd and type music, and now we are in that directory. You can see the indicator showing that we're in that directory. If we do an ls, we can see everything in that directory. The other command I'd like to show is make dir. Firstly, let's go back to the previous directory, which was the user directory. To do that, we do cd ... In this case, ... means go to the previous directory. Alright, so we can see that we are back to the user directory, and to make a new directory, we would just say make dir, which is pretty much make directory. That's the short version of that. And now we're going to type directory name. I'm going to say dev for developer, and if we do ls, we can see that that directory has been created. To go into that, we will do cd and dev. Alright, so if we do ls, we'll see it's empty. The other command is clear, which just clears everything in the terminal to make it look nice and clean. And now what we can do is type, if you have Visual Studio Code installed, you can type code and dot. Dot means to open the current, to open Visual Studio Code in the current directory. Remember, dot meant the previous directory, but if it is just a single dot, it means to open it in the current directory. And I have Visual Studio Code open now, and currently I cannot work with C++ or C files because I deleted the command line tools, so we're going to install it. Let's go to the user directory, and if you are like 7 directories deep and you want to quickly go back to the user directory, you would do cd and tilde. Once I hit enter, I am back to the user directory where we can see everything that I have. Alright, so the first thing we want to do is let's install the command line tools. So you don't really need to install Xcode entirely. You can just install the command line tools to work with the necessary commands. So we're going to type xcode -select --install. And now it is going to give us a pop-up window. We're going to say install, agree. It will take a few moments to install everything that we need. Alright, Xcode has been installed, and to verify, we're going to type xcode -select -p. P stands for path, and now it gives us the path that it is installed in. We could go to that path. You can see that what you can do is you just type the first few letters, hit tab, and it brings you, it gives you the entire name of that directory, which is useful to speed things up. We're going to cd into the user, we're going to cd into bin. This is just to demonstrate the number of command line tools. We can see there are a lot of tools here, but we're mainly going to use GCC. There's also a G++ tool, which is mainly for C++. Now, a lot of people mistakenly use both of these interchangeably, but they are not. And just to remember that GCC is for C and G++ is for C++ will save you a lot of headache. Alright, so let's go to the user directory. I'm going to clear the terminal. I'm going to do ls, or we will go into the dev folder. I'm going to create a new directory with makedir. And you can see the structure is really nice when you have a developer directory in the user directory to nicely structure your code and your project. So I'm going to cd into the dev directory I just created. Oh, I created example. Alright, so if we ls, we can see that it is empty. We can do code dot to open Visual Studio Code in that current directory. We can press the plus icon to the top left to create a new file, and we can say main.c. I'm going to create a hello world program just to illustrate how to compile the C file and turn it into an executable. Alright, I'm going to save it by clicking Command S, or you could go to the file from the top left and click the save option. Alright, let's close this. If we do an ls in the example directory, we can see the main.c file. Alright, to use GCC, we're going to type gcc main.c -o, and right there, we're going to write the name of the executable that we want to have. If you just leave it like this and hit return, it is going to ask you to type the name of the executable. Or you could do the same thing, .c, without providing the -o, and if you hit return, it is going to create a.out, which is going to be the executable. But if you want a custom name for your executable, you can do gcc main.c -o, and you can type program or output. It really doesn't matter. So now if we do ls, we can see that we have output. This is an executable. This is also an executable. We just didn't specify a name for that executable, so it is it defaults to a.out. Alright, to remove a.out, we can use the rm command, a.out, ls, and nice. It is clean. We have our executable output. Now to run it, we're going to say ./output. And again, I wrote the first two letters, I hit tab, and it filled out the rest on its own. We hit enter, and we will see that hello world that we have in our C program, the printf. Alright, so what about if we had multiple C files? Alright, let's try to have something. Let's say a new file, message.c. Well, I'm not going to put anything in there, but just to demonstrate how you would do that. If you have gcc main.c message.c -o and output. Oh, it says that message, because I made a mistake in the name of the file. That is easy to fix. I have 3 S's instead of 2, so I can fix that quickly. And now if we do that, we can see that we were able to create the executable. Even though my message.c doesn't have anything at the moment, but I just wanted to illustrate that you can put out different C files like this in a row to create your executable. Now let's actually use the message.c that we've created. I'm going to have a header file for that, message.h. My header file is going to have, well, first let's remember that we need to have if not defined. Let's say my message functions and I'm going to say define my message functions, and let's end that if. This is essentially a guard code to make sure that we don't define this header file twice. I'm sure you already know this, but it is a good idea to type these just for practice. Most modern IDEs will type this for you when you create the header file, but it is still good practice. Let's declare a function called message hello, and now we can go back to the message.c and create that function message hello. I'm going to say, actually, first we have to remember to include the libraries that we're going to use, and include the actual header file. In our case, it's message.h, and I'm using the quotation marks. I'm using quotation marks to include that, but for the libraries, it is actually these less than or greater than brackets, or whatever they are called. So now when I save it, it's going to structure it this way. This is preference, it doesn't matter. I'm not sure what's the best way to do it, but let's continue with our code. Now, if we do printf, hello, this is a message, and all right, that is our code now. And what we can do, we're going to go to main.c, we're going to include the message.h, and we can now call message hello from the other file that we have, and make sure that everything is saved. All right, we can go back to the terminal. I'm going to clear everything. If we do gcc, actually, let's first see what we have here. All right, we have a bunch of things. We have main.c, we have message.c, and we have message.h. If we wanted to compile both of these, we would do gcc main.c message.c -o and the, let's say, program this time. Now if we do ls, we can see the program, that is our new executable. If we do /program, we can see we have hello, this is a message. If we do /output, we can see this is the old executable. All right, that is pretty good for a head start. And another thing that is useful to know is that you could essentially create object files for these two and then link them together later. To do that, let's actually clear these executables because we don't need them. All right, the executables are gone. So the way you would create an object file is you would say gcc main.c message.c -c. And now once we hit enter, we ls, we can see these object files. These are not executable. Oh, here you go. These are not executable. These still need to be linked. The reason why we're doing this is because when you have thousands of files, and let's say the main.c file has hundreds of lines, and it takes quite a lot of time to actually compile that, but we don't actually make any changes to it. We only made a few changes to message.c. We would basically create a message.c object file, and then we would link that to main.o object file that we had created previously, and there haven't been any changes to main.c, so we can just use that object file to link it to the message.o that has actually been changed. And there's actually a good way to automate this, which is by the usage of the make command line tool. It is basically it's called make, and you create a make file and define all of the C files and all of the object files that you need to create. I can make a separate video on make. However, for this class and for this project, I think you should be fine with the command line. However, I will make that video if anyone wants to see how to use make. It is quite simple. All right, so now how to actually link these. Main.o and message.o, these are actually objects. They are not executable. To link them, we'll do gcc main.o message.o, and now we can do -o, and we can give it the program or the output name. And then if we do ls, we can see that we have a program. This is now an actual executable. So if we do /program and we run it, we can see that this is the hello message that we have in our message.c file. And that is pretty much it. You can have multiple files. Well, you can combine them with the command to compile them. And there is a really good tool. You can look it up. It is just a make tool. If you do make, it might give you, here you go. There is a manual for that. It is a really good tool. I could do a quick video if you guys want to demonstrate how to use it, to essentially just have a list of things that you'd like for it to watch. And when you actually want to compile, it will check to see which file has changes in it so that it will only compile that file. For this specific project, it doesn't matter because we don't really have that big of a project. The files aren't that big, so it won't take that long to compile. But later in life, if you do a really big project, that is going to matter a lot. That is pretty much it. Thank you for watching.